All right, so 5.1 goes over exponents with positive, negative exponents, zero exponents. Your whole idea when you're working with these is to always end with a positive exponent. With these powers, if you're starting with a negative exponent, you got to turn it into a positive one. So you would have to take the reciprocal of the number that that negative exponent or that negative power is attached to in order to turn it into a positive. So if we look at some examples, if we have example 1a, we have 3 to the power of negative 1. We want to turn that negative 1 into a positive 1 as that power. So we're going to take the reciprocal of that 3, which will turn that 1 into a positive 1. So it would just be 1 over 3 to the first power, which is just 1 over 3. For example B, we have 1 over 5 to the third power. Well, that 5 to the third power is the same thing as saying 5 times 5 times 5 3 times. So you have to simplify that. So the 5 times 5 is 25 times 5 is 125. So that's just 1 over 125. For C, we have 3 to the power of negative 2. So for this one, we're going to turn that negative 2 into positive 2. First, take the reciprocal of that 3. So that's 1 over 3 to the second power. 3 to the second power is just 3 times 3, so that's 1 over 9. For example D, we have negative 3 to the power of negative 2. We got to turn that negative 2 into a positive 2 first, so it's going to be 1 over negative 3 squared. That negative 3 times negative 3 is what we will do on the denominator there. So we're just going to be left with 1 over 9. For E, you're given negative 3 raised to the negative second power. So with this, that negative 2 for that power is only attached to the 3, not the negative. So this negative, it's like saying negative 1 times 3 to the negative second. So that negative 2 as a power is only attached to that 3. So take the reciprocal of just that 3 to have it be 1 over 3 to the second power to turn that negative 2 power into a positive 2 power. From here, simplify the 3 squared. That's 9, so that's negative 1 times 1 over 9. The negative 1 times 1 over 9 is just negative 1 over 9. With these, you want to be careful. If you're left with a negative, you want to keep it either in front of that fraction or in the numerator with that 1 in this case. For example, F, we have 3/4 raised to the negative third power. First, turn that negative 3 into a positive 3. Take the reciprocal of that 3/4. So that's going to be 4 over 3 raised to the third power. From here, you take that power and distribute it, sort of say, to both the numerator and the denominator. So you're going to do 4 to the third power over 3 to the third power. That 4 to the third power is 4 times 4 times 4. That 3 to the third power is 3 times 3 times 3. 4 times 4 is 16, times 4 is 64. 3 times 3 is 9, times 3 is 27. So that just simplifies to be 64 over 27. For your next set of examples, we're just simplifying each of these expressions. If you have a number raised to a power that is 0, it turns that number into 1. So if we look at example A, we have 3 to the power of 4 times 3 to the power of 0. Now, our bases here are the same. However, with this, okay, so there's two things here. Your bases are the same and they're separated by multiplication. So with that, you could keep the base and add the exponents. However, this 3 to the power of 0 is going to turn into a 1 as well. So this 3 to the fourth power times 3 to the power of 0 is just 3 times to the fourth power times 1. So we're just doing 3 to the fourth power, which is 3 times 3 times 3 times 3. Now you know 3 times 3 is 9. Both of these are 9. Multiply the 9s together, you get 81. So this 3 to the 4th power is just 81. With example B, you could do this one of two ways. You could say your bases of the x are the same, so I can just multiply the coefficients of these two and add the powers on the x, which the one that's just that 5x has an invisible power of 1. Or you can simplify that x to the negative third first by giving yourself 4 over x to the third power times 5x and put that 5x over 1 and just multiply straight across. If you did this, the 4 times 5x gives us 20x, and then x to the third power times 1 is just x to the third power. Now when you have a variable with a power in the denominator and the same variable up top, the power of each of them gets subtracted, and wherever it ends is going to be where the bigger number is for the power. So you have a 1 as a power on the top, the 3 on the bottom. You would cancel out that x to the first power on the top and subtract the 1 from the 3 on the bottom, keeping it in the bottom. So it would just be 20 over x squared. For example C, we have negative 2y to the negative third power times negative 5y to the negative fourth power. So with these, we could do this one of two ways. So the one before this, I simplified before I did anything. This one, I'm going to keep my powers and add those exponents and multiply the coefficients. So here, I'm going to do negative 2 times negative 5, keep the y, add the negative 3 with the negative 4. So the negative 2 times negative 5 gives us a positive 10. The y we keep, the negative 3 plus negative 4 gives us negative 7. That negative 7 for that power is only attached to the y, so you need to simplify this and take the reciprocal of that y to the negative 7th power to turn that negative 7 to a positive 7. So that 10 is going to stay on top, and the y to the 7th power will just go to the bottom of that fraction, and that 10 over y to the 7 would be your solution here. For example 3, again, we're just simplifying these. For A, we have negative 3 raised to the power of 0. So once again, this negative 3 to the power of 0 is like saying a negative 1 times 3 to the power of 0. That 3 to the power of 0 is just 1. So this is the same as negative 1 times 1, which is negative 1. For example B, we have 1/4 minus 3 over 2, all raised to the power of 0. Again, anything to the power of 0 is 1. So this entire thing just becomes 1. For example C, we have negative 2a to the 5th, b to the 6th, times 3a to the negative 5th times b squared. So you can do this one of two ways. Again, you can take all of your coefficients, multiply those together, and then deal with your exponents with those like terms. If I did that, I would just do the negative 2 times 3, then have a to the 5th power times a to the negative 5th. Then I would have times b to the negative 6th power times b squared. And I could combine those b's and those a's by adding the powers on those. The negative 2 times 3 is negative 6. The a to the 5th times a to the negative 5th is a to the 5th plus negative 5. And that b to the negative 6 times b squared is b to the negative 6 plus the second. If we simplify these, that 5 plus negative 5 is 0. So that's negative 6 times a to the power of 0. That negative 6 plus 2 is giving us b to the negative 4th. So if I simplify these, that a to the power of 0 is a 1, so it cancels out. That negative 6 will stay on top. That b to the negative 4 goes to the bottom to turn that negative 4 into a positive 4. So we just have negative 6 over b to the 4th power. For our next example, or set of examples, we are writing each expression without negative exponents and simplifying, and we're told that all variables represent non-zero real numbers. So with example A, we have 5a to the negative third over a squared times 2 to the negative second. That a to the negative third has to go to the bottom of the fraction, and that 2 to the negative second has to go up top to make it a positive 2. So this 5 is going to stay up top. That 2 to the negative second is going to go up top as well and become 2 times 2 to the second power. The a squared stays on bottom, and then the a to the negative third goes to the bottom as well to make the negative 3 a positive 3. So here we're just going to simplify. So we're going to have 5 times 2 to the second power is 4. On the bottom of the fraction, we have a to the second times a to the third, so we're going to keep the a, add the 2 and the 3. 5 times 4 gives us 20. A to the second plus the third is a to the fifth. So that's 20 over a to the fifth power. For example B, we have negative 2x to the negative third power over y to the negative second z cubed. That x to the negative third is going to go to the bottom. That y to the negative second is going to go to the top. That's going to turn these powers into positive powers. So we're going to have negative 2 times y squared over x to the third times z to the third. With this, there is no more simplifying, so you're just giving the negative 2y squared over x cubed z cubed as your answer. In example 5, we are just simplifying these expressions once again and not leaving any negative exponents. If we look at example A, we have 2 to the 9th power over 2 to the 4th power. Our bases are the same for both our numerator and the denominator, so we can subtract those exponents and leave the power where it is positive. So if you look at this, the 9 is greater than the 4, so we're going to bring that up. So it gave us 9 minus 4 in our powers. So that's just 2 to the 5th power. Now this 2 to the 5th power, you can also simplify. It's just 2 times itself 5 times, which gives us 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32. For B, we have m to the 5th power over m to the negative 3rd power. We have to turn that negative 3 power into a positive 3, so we're going to bring it up top. We're going to have m to the 5th power times m to the 3rd power. Our bases are the same, so we're going to keep the bases, add the powers. 5 plus 3 gives us 8, so that's m to the power of 8. For example C, we have y to the negative 4th power over y to the negative 2nd power. If you want to turn these both into positive powers first, we can just switch these values around to where we have y squared over y to the 4th power. This is the same thing as saying that 4 as a power is greater than that 2 as a power. So I'm going to end in my denominator, so this y squared is going to be subtracting that 2 from that 4 in the denominator and become a 1. So this is just going to be 1 over y squared. For our last set of examples, we are using the rules of exponents to simplify each expression and writing answers using positive exponents only. For example A, we have 2x to the negative 7th power over x to the negative 7th power. We know that when a base is raised to a power is over itself, they cancel out, so we just have 2. For example B, we have w times 10w to the negative 4th all over 6w to the negative 2nd. So with this one, if I multiply my numerator first, I'm going to have 10 times w to the negative fourth plus the first. Since I'm multiplying, I add the exponents if my bases are the same, all over 6w to the negative second. If I simplify that numerator, I'm going to have 10w to the negative third over 6w to the negative second. If I then want to take these negative exponents and turn them into positive exponents, I'm just moving that w to the negative third down and that w to the negative second up. So this is going to give us 10w squared over 6w to the third. I see that my bigger power is in the bottom of my fraction, so this w squared is going to cancel out, and I'm going to subtract the 2 from the 3, keep it in the denominator. This is giving us 10 over 6w. My 10 and my 6 can now simplify. They're both divisible by 2. So the 10 is going to become a 5. The 6 becomes a 3. So this gives us 5 over 3w for our final answer. For our last example, C, we have x to the power of negative 1 times x to the power of negative 3 times y to the power of 5 all over x to the negative second, y to the negative second. My whole thing here is to get rid of these negative exponents first. So I'm going to take that x to the negative 1, bring it down, x to the negative 3, bring it down, that x to the negative second, I'm going to bring it up, and that y to the negative second, I'm going to bring it up. So this is going to leave me with x squared, y squared times y to the fifth, all over x to the first times x to the third. From here, I'm going to simplify by multiplying here. So that x squared times y to the fifth, I'm going to add those exponents with the y's. On the bottom, that x to the first times x to the third, I'm going to keep the exponent, the x, and add those powers. So 1 plus 3. This is going to leave us with x squared times y to the 7th power all over x to the 4th power. Now between my x values, I have an x on the top and on the bottom. That 2 is less than 4, so I'm going to end up with my x value on the bottom, and I'm going to subtract those exponents. So I'm going to cancel out the one on top, take 2 away from the 4. This is going to leave us with y to the 7th power over x to the 2nd power.